we're going to be starting for the next few days talking about those imaginary numbers that we were talking about. And so imaginary numbers is also called complex numbers. You get really excited about imaginary numbers. There's a whole part of math that is all about imaginary numbers. I actually took that as my elective in college. I took a whole class about, on purpose, all about imaginary numbers. The only bad thing was the professor was really nice, but part of it was hard because you had to decipher what he was saying. So like hypotenuse would have been hypotenuse, 3 was tree, so you had to kind of interpret. So anyway, so imaginary numbers you can do so many things with them, but we're just going to touch the basics. So number 1, can we simplify a radical using imaginary numbers? So that's what we're going to be working on today. And then we're going to also be able to define and work with that number of the imaginary number known as I. So that's what we're going to be working on. And then, of course, later on, we'll be talking about operations. So what can I all do with the magic number of I? And so we'll get into that. All right, so what is I? Okay, so when we look at this picture, remember how in the past we kind of said there was no real answer because where is this parabola going to cross the x-axis? Never, right? So that's where that's coming from, because that's the obstacle. By looking at the picture, we can see that the picture of this particular function is never going to cross the x-axis. If we decided to solve it instead and do like the quadratic formula, then we're going to get the square root of -16, and you've always been taught that you can't do that. So you can't have a square root. And so your past experience tells you that there's no real number that has -16 as its square. And so for many years and thousands of years, mathematicians just said that is no solution and that's it. Okay? And then so later on, they decided, so this was around 16th century, then that all we needed was a new kind of number to represent all these crazy negatives in the square roots that, you know, that existed. And so that's where they kind of came up with this whole new number system, which is called imaginary numbers. And then it became more accepted later on. So it took a few centuries. The thing is about math, people, first of all, math is really, really old, hasn't changed for many years, like lots. And also it takes quite a while for change to go work in mathematics. So like when people first propose things in mathematics, usually they're like shunned. People don't like that kind of idea. And then later on, people become more to accept it, but it just takes a while. And that's kind of what's going on. All right, so again, some of the obstacles, again, was just basically talking about how you could deal with that and deal with that -1. And so that's where we're dealing with that lovely number I, okay? So I represents the square root of -1, okay? So they came up with this whole new number system. And so the whole new system is called complex numbers or imaginary numbers. And so if we find anything that has a negative square root, we're going to replace that -1 idea with I. And so if we have like the square root of 7, that's considered a real number. 5i is going to be an imaginary number because it's got I in it. And you can also put I in things, like you can add, subtract, multiply, and divide. So there's lots of things you can do with I. Okay, so let's go back to what we were doing before. So remember, like on our quiz, we started out with like the square root of 72, or some of you guys had the square root of 63, if I remember, for the first question on your quiz, right? So the first part is just giving you lots of background on this. So that's what this first page is all, just kind of the background of where did I come from. Okay, and so like, for example, if we have the square root of -9, before we would always say, you can't do that. Okay, well, yes, we can. If we set up a whole new set of numbers called imaginary numbers, what we can do is change this into what I have here. So I can change this, so this is really 9 times -1, right? And then we'll break it apart. Okay, and then yes, and so we know from this, so the square root of 9 is 3, and so this is going to be 3i. And that's it, we just write 3i, because we know that I is the same as the square root of -1. And so that's what we're dealing with there. Okay. Then we get to the next piece. So if we have the same thing, this one we're going to split apart. So this is just going to be 64 times negative 1. And again, we're going to have the square root of 64 times the square root of negative 1. And then we know what the square root of 64 is, right? 8. And then we know the square root of negative 1 is called I. So then here's my answer. It's 8I. So 8I. Okay. Next one, we can do the same thing. We'll keep the 4 plus or minus, but then we'll change this. So this is not going to be negative 100. This is going to be a negative 100, or probably positive 100 times negative 1. And then again, break this apart. So we'll have the square root of 100 times the square root of negative 1. So we're going to have 4 plus or minus what? 10I. So we're not really learning anything new. What we're learning about is how do I deal with these crazy problems that maybe won't work out. So when we go back and look at some of our quadratic problems that we did in the past, we'll still have our answers work out like you did on the quiz, but you also might have some that are imaginary too. So again, just like before, how we had some simple equations, here's a simple equation. We're just going to solve it. It's just that this one's a little bit different. So here, of course, what would we do to solve this algebraically? Minus 1. So we'd have x squared equals negative 1. And just like before, what would we always do when we did our last quiz? Square root. So I'm going to square root both sides. So x is going to equal positive and negative. Don't forget I put that positive and negative in. And then what is the square root of negative 1 called? What is it called? I, because it's for imaginary numbers. So that's my answer. My answer would be plus or minus I. Well, it's going to be fine. It looks complicated. It's not complicated, but I will help you. Okay, so yes, lots of funky things with I. All right, now what that means is I to the 0. Do you remember anything like an exponent to the 0 power? If you remember back from algebra, anything from the 0 power is always going to equal 1. And that's going to actually follow us when we go to the next chapter, which is called polynomials. So if we have I to the first power, then that's just considered I. Remember, I is just the square root of negative 1, right? So when we think of I squared, that means really, in essence, we're having the square root of negative 1 times the square root of negative 1. Well, what happens to my negative when that happens? It cancels because this becomes the square root of 1, but what is the square root of 1? 1. So that's why we have, well, technically we have that, and then we have to account for that one as well. Because technically, if we think about that, if we have this, this is really going to be, is this will just be negative 1 squared, so therefore this is negative 1. We're not going to worry about the positive and negative. This is why. Here, let me explain that one more time. Let me do a better job. So this is really written as negative 1 squared, right? And what does the square and the square root do to each other? So that's why it's negative 1. That's a better way of saying it. And then when we have I cubed, then I'm going to have negative 1 times negative 1 times negative 1, okay? But remember how this turned out to make negative 1? This is just going to be I. So therefore, we just call that negative I. So this is just talking about powers of I. So it just shows, and if you kind of look at it, you hopefully will see that there's kind of a little bit of a pattern. So, and then that's what we can kind of use. We can use that pattern to kind of figure that out and figure out what it is. And I'll show you how to do that, okay? So first of all, this isn't too bad. So if we have 2I and 7I, this is just like 2x times 7x. Same idea. So what do you think we're going to do with the 2 and the 7? We're going to multiply them. What are we going to get? 14. And then how many i's do we have? 2. Everybody okay so far? We have 2 i's. Okay, now we're not done. Okay, so now the biggest thing I want you to know is I squared. If you don't know the other ones, I really could give 2 hoots. but you need to know what I squared is, okay? I squared is always -1, okay? So this is really 14 times -1, so what's my final answer? -14. Ta-da! So if you have a single eyes are good, okay? Big exponents of eyes, we want to simplify. Like 26, yeah. Because, I mean, who's going to sit and want to count through this chart and figure out what the heck is I to the 26? Right. Now, do you remember when we work with exponents, do you remember what we do with the exponents? Like, that means, do you remember if you add, subtract, multiply, divide? Do you remember anything? Like, for example, back in the days of algebra, x to the 5th really could be x cubed times what? So x to what power? That's what I'm asking. Because we're really not multiplying these, we are adding them. So what we got to do is figure out how the heck are we going to get 26 out of the stuff that we have up there. So any of those wonderful things go into 26? So we want to come up with 26. So how about we use, like, would 10 work? So what if we had I to the 10th times I to the 10th times I to the what? What do I have left? 6. Because that makes 26, right? 10 plus 10 plus 6. Okay, so now I got to figure out, okay, what's I to the 10th? -1. Okay, so I'm going to have -1 times -1, and then I got to figure out what the heck is I to the 6th. And I to the 6th is also -1. So what's -1 times -1 times -1? -1. Done. Simplified. So it's kind of weird. Okay, if we did I to the 23rd, what do you think we would do? So how could we break that apart? Couldn't I do the same thing? Yeah, let's just do I to the 10th times I to the 10th times I to the 3rd. So we already know this is -1 times -1. Now we got to figure out what I to the 3rd is, which is -I. So if I have -1 times -1 times -I, what will it make? Well, what's -1 times -1? Okay, so that's going to be 1. Now do 1 times -I. -I, that's it. So there's my answer. It's simplified. And then if I did the 30th, I would just do what I did in number 26, but just do I to the 10th times I to the 10th times I to the 10th. And I'm just going to have -1 times -1 times -1, which is -1. So this is just playing with eyes and kind of learning how to simplify. Are you really going to see a lot of that in the mathematics you do? No. This is what you need to know. Okay? You need to know that. Okay? So you need to know what I represents. I represents the square root of -1. And you need to know that I squared equals -1. If you can memorize those two things, you're golden. Okay? This is just showing, like, with different powers of I, what we can do. Okay? And so we can do math with I. Doesn't that sound like fun? Yeah? No? No? Yeah? It is. It's so much fun. So it really is going to be fun. You'll like it. Trust me. So it's just like days we're not going to be graphing for a few days, not till Wednesday. So this is just like X's. So when you think of I, think of an I like another variable, like an X or an A or a B, and you go right back to Algebra 1. So when we take a look at number 1, what looks alike? So we're going to go right back to like terms. So does the -6i have a friend? No. Okay, so he's going to stay where he is. So let's put our other things together. So we're going to have -8 minus 3 plus 5. What do we get? So we'll get -6. Everybody okay so far? And then I've got my I term left over. Usually we put the imaginary number at the end because we like the real numbers to go first, then the imaginary. So that's kind of what we do with that. So that's my answer. So I simplified, put together what I could put together. And it really isn't any different than having like an X or an A or a B or whatever. Okay, what happens when we have a minus and then parentheses? So what are we going to do with that? Right, so we're going to have a plus, this is going to become plus, this is going to become plus. So now I can look and see, okay, number-wise, not imaginary-wise, but number-wise, what can we put together? Feel like we're not awake on a Monday. So 5 plus 3, which is? 5 plus 3, 8. And then do we have any imaginary pieces we can put together? Yes, the 3i and the 5i, which will make 8i. Done. So we're kind of learning some operations before I can throw back to some of the quadratic stuff that we did. So I got to teach you some of the little funky things about I. All right, next one. Notice we're doing some timesing in the beginning. So maybe let's multiply these two things together to kind of clean up a little bit. So what do you think negative 5i times I would be? Yes, it'd be negative 5i squared. Okay, and then I'm going to have it eventually multiplied by negative 5 times 8i. Now, remember how I didn't want you guys to worry about other powers of I? What I would do is this. We know, remember, I just told you, you need to know what I squared is. What is I squared? Negative 1. So what's negative 5 times negative 1? Okay, I'm going to change this right away so then I don't get super duper big powers of I. So I have a method to my madness. Okay, so I cleaned that up, so now I'm not going to have higher powers other than squared out of my i's. So now, 5 times negative 5, so that'll be negative 25, and then 5 times 8i, which will make 40i. Wild indeed. So it's just like polynomials, except that you've got i's that you have to kind of take care of. Okay, this one's kind of cute. You just have to multiply it out and then worry about the subtraction. So we're going to have 8i times negative 8, so that's negative 64i. So this is like the distributive property. We do this in algebra. So 8i times negative 2i, which would make negative 16i squared, minus, now I got to multiply the other stuff out, 8i times 1, which is 8i, and then 8i times minus that 5i, which would be negative 40i squared. So I'm not going to clean it up just yet because I think we can put together some like terms. And remember, there's a minus here, so we can throw this minus through like we did before. So this now becomes negative. This now becomes positive. So is there anything that looks like the negative 8i that I could put together with it? Yeah. So I'm going to have this. So we're going to have the negative 8i and the negative 64i. So then that will make negative 72i. Does that sound right? Then these two get to be put together because they're both I squared, right? So as long as they have the same exponent, we can put that together. So 40 minus 16, which will make 24i squared. Now, are we done? No. One last thing. Remember I told you about I squared. What is I squared? Negative 1. So what's 24 times negative 1? Negative 24. So then my answer to this problem of number 4 would be negative 24 minus 72i. I'm putting the negative thing in front just because, again, I want that imaginary piece at the end. And there's Emma. Okay, this next one, number 5, I should have left more space for me on the board. Yuck. So for number 5, do you remember doing FOIL or double distributive or whatever you would call that? You get to do that fun stuff with I. And if you like that, you know, some of you guys used to do these little boxes. Anybody remember the little boxes? You could do that too. That works beautifully with imaginary numbers. So I could do this. I mean, do I sit and do this with the boxes? No, but you can. So you could do like, what is 5 times negative 2, which would be negative 10. Then negative 2 times negative 7i, which would make 14i. Then we'd have negative 2i times 5, which is negative 10i. And then negative 2 times negative 7, which would make positive 14i squared. Or you can multiply it out if you remember in the past how you just multiply it through. I just call it double distributive. I first take 5 times the negative 2, then I do 5 times the negative 2i. And then I do negative 7i times negative 2, and then negative 7i times negative 2i. You still get this. So now I'm going to clean that up. So I've got a 14i squared. And then these two are like terms. So that's going to make a 4i. And then I have a negative 10. Now, we're almost done. What can I clean up? Remember, I squared. Anything with I squared's got to get cleaned up. And so I squared is negative 1. So therefore, what's 14 times negative 1? Yes, but now he's got like terms with somebody. Right, so we're going to put those together. So negative 14 and negative 10 make negative 24. So my answer becomes negative 24 plus 4i. And then the last one is actually not that bad at all. This one we have to just do distributive and look for like terms. So here I'm going to distribute. I'm going to have 21, and then we're going to have a plus 28i. And then I'm going to run this minus through with the negative 5. So negative 5 times 6 would be negative 30. And negative 5 times 7i would be negative 35i. And then now we just put together like terms. So 21 minus 30 is negative 9. And then these I can put together, and that would make negative 7i. And we're done. So we don't need to worry about the I squareds unless we are multiplying. Okay, if we're multiplying, then the I squared shows up. Notice how when we added and subtracted, then that became a little bit more of an issue. And then I forgot about poor little 7, because he's the last one. What do you think's wrong with him if I have 9 over 4i? Remember, this is the same as saying 9, and then remember what this really is. This is like 4 times the square root of negative 1, so what's wrong with it? We can't have that in the denominator. So remember, that represents a radical. So what could I multiply that by that would make it work? Remember, that's negative 1, the square root of negative 1, so I could just multiply it by I. But if I multiply the bottom by I need to multiply the top by I. Yes. So 9 times I is 9i. This will become on the bottom 4i squared, but we don't want to write 4i squared because we know I squared is negative 1. So what's 4 times negative 1? And then there we go, negative 4. So we can't leave an I in the denominator because that's like a form of a radical. So what do you think of this crazy imaginary math stuff? So we'll clean up what we need to do that tomorrow, and then we're going to talk about how do you do problems that we were doing before involving I. Okay? So first we need to be able to play with I and be able to get that to work.